Hi, welcome back. And the topic that we are going to discuss is sketch the graph. Yes, if you haven't watched part 1 and part 2 of this topic, I request you to go and watch. I'll be providing the link in the description. So first go and watch part 1 and part 2 where I have discussed how to find out the how to find out an equation of line using graph in part 1. um, and also I have also explained you very well how to find out how to plot or sketch the graph of a line equation. Yes, if you have not watched this two part, it's like very must to watch that before watching part 3. So in part 3 we are going to discuss about the topic basically on the curved graph, because we already focused on the line graph. So in part 3, this is part 3 video, so we'll be discussing more towards the curve graph. And as you all know that I already mentioned a linear graph, that is straight line graph. If we have this type of graph, it will be called as a positive graph. And if we have this type of graph, then it will be, if we have this type of line, then we can say it is a negative line, because the magnitude or the gradient will fall down like negative, right? So that's how it looks like. An equation of line can be written as y equals to mx plus of c, and c is the point where it cuts the y-axis, right? And m is the gradient. M is rise over run. We all actually discussed these things in part 1 and part 2, so watch through that. So and now we'll be discussing about some of the parabola or the quadratic equation that is actually called as. So quadratic equations. I also mentioned a little bit about a quadratic equation where the highest power, highest or the maximum power, highest power should be square, right? Highest power is 2, or square, we can say that highest power is 2. So for example, if I give you an equation like y equals to 2x square plus of 3x plus of 2, here in this equation you can see that the highest power is 2 over here. That's why we'll be calling this as a quadratic equation, right? And yes, how to, as we know that in a line case, uh, we have discussed the line goes up, and while it comes down, it will be called as negative line. And the same way, we'll be having some sort of graph of quadratic in which we can identify whether it is positive or negative. Let's say this is our axis here, y-axis and x-axis here, and if we have a curve like this one, right? If you have a curve like this one, and we'll be calling this as a quadratic curve, right? Quadratic or parabola, usually we call this as a parabola, or according to you it's like quadratic. So if we have u shape like this one, then we will be calling this as a positive quadratic graph. And if we have like this one, if it goes opposite to you, that is like in this phase, then we'll be calling this as a negative quadratic graph. Okay, so keep it in mind. And also negative and positive, it's being affected in magnitude, right? So this is actually m over here actually. So this will be like showing us the positive, whether the graph is positive or not. Let's say if I give you an example, y equals to minus of 3x square plus of uh, minus of 3x square plus of 2x. Okay, in this case the graph will be positive or negative. How the graph will look like? Because the equation where the x value is like in a magnitude where the x has the negative value actually in minus of 3, so it will be like this one, right? The graph will be opposite to you, right? If in the same way, if the equation is given in this way, let's say if the equation is y equals to 3x squared plus of 2x, if it is 3x square plus of 2x, let's say this is an equation, then instead of going opposite, it should have gone like this one. Okay, these two things you have to keep it in mind. In positive case, it will be like u, and if it is in negative, it will be in the case of opposite to u. So another thing that you need to keep it in mind, that is where does it this graph touches the y-axis actually. So you can see that this graph of mine is touching the y-axis at point, let's say this is 1. I'm just assuming we'll give you some questions based on that. This is minus 2, right? This is minus 1 and this is minus 2. So that is the point actually. Here it should be like the equation should be like minus 2 over here, right? So wherever it touches the graph, that will be the C point. Actually, you know, this line also have C, and it's the same point where it touches the y-axis, right? The same way we'll be deciding at what point it's touching the y-axis. So you can see that it is being touching the y-axis. This is y-axis, right? This is y-axis. So here it's touching the line at the point at minus of 2, so the C will be minus of 2 over there. And the same way, if we have the equation like y equals to, let's say this is 1 and this is plus of 2, okay, and the curve touches the y-axis at plus of 2, the equation may be in this format because it's a negative, so it will be minus of 2 x square plus of 3x, then plus of 2. So why it comes out to be plus of 2? Because it's being touching the y-axis at plus of 2. So the two things that you should keep it in mind, whether the graph is positive graph, or whether the graph is negative graph, and at what point the graph touches the curve, at what point the graph touches the curve. Here the graph touches the curve at negative or whatever, like negative 1, negative 2. Here the graph touches the point at positive 1, positive 2, and that will affect the equation, right? Equation in sense that is the last, y equals to 2x square plus of 3x plus of minus of 2 over, actually for this one it will be minus of 2, and for this one it will be plus of 2, right? So it will be like changing according to the graph formation. So the basics is this for the quadratic graph. And let me give you a quick review on the cubic graph also. So let's say a cubic graph or cubic equation graph. The highest power should be 3, right? And 3 in sense, like if you are writing y equals to uh, 3x cube plus of 2x square plus of 3x plus of 4, right? This is the equation. And you can see that the highest power is what? Highest power is 3 over here. This x is having the highest power, right? 3, because there is no other number that is bigger than 3, that is called as actually it's not there is no other value, the number that is greater than 3. So highest power in the equation is 3. That's why we'll be calling this as a cubic equation. Okay, then you have to remember, as for now we have done the quadratic equation as u, positive u, and the negative u, and this cuts the point, and we'll be calling that C. So the same way, we can also say that this graph, you have to remember the pattern of the graph, how it looks like actually, a cubic graph. If we have a cubic graph in this format, see, we can call this as a cubic graph because a cubic graph has 3 solutions, right? You can see that it's a cube, so it will be having 3 solutions. It will be meeting in 3 point of the x-axis, 3 solutions. This will be x1, this is x2, right? And this will be x3. And the quadratic graph, as I told you, that it's going to be u-shaped, so it will be having a 2 solution because it's going to meet only 2 points here and here, right? So same way the cubic graph will be having a 3 solution. And this is a positive graph. How to identify it's a positive? When the right hand side, see, this graph is going like this, and the right hand side part, this is right side, so this is left. So right hand side, if it goes up, right hand side, this is right and this is left, right? If right hand side goes up, it's a positive graph. Okay, and in the same way, if the right hand side goes down, this is the right hand side according to my drawing, this is the right hand side, this is left, right. I'm starting from the left and I'm going to right. So if right hand side goes down, this will be negative graph. Okay, so this is how it looks like. Let me give you uh, with proper diagram here. And here you can see that this graph is a positive graph. So we can also, you have to note it that from where it crosses, let's say this crosses from plus of 1. So the equation whatever you're writing, the last value will be plus of 1. Okay, and that's what actually makes a sense actually. The if the positive graph is there, here the sign will be positive. And let me give you like little bit of examples. It will not be the perfect equation, but let's say this is y equals to 2x cube plus of 3x square plus uh, of 2x uh, plus of 1, because it comes to be plus of 1 by this way, right? Because it's meeting at plus of 1 in the y-axis, right? And it has been observed that this graph is a positive graph, so it will be positive. So I'm not sure about this equation, whether this is the actual equation of this graph or not, but I can say that this is a positive graph, because it the right hand side goes up, it's a positive graph, and it will definitely meet at point plus 1. Same way, if I take a negative graph like this one, as I told you, if I take a negative graph, it will be like this one. So the right hand side will fall down. In this case also we may have three solutions here. So x1, x2 and x3 here. And what we can identify that this graph where it touches the y-axis will become the uh, constant, that is c, actually the last value. Okay, the number, let's say this is minus of 3. So what will be the equation of this one? It's just a rough equation, it's not the exact equation, I'm just giving a rough equation. But this equation will definitely have a negative on it, because the graph is falling down, right, like this. So it will be having a negative. Let's say this is minus of 2x cube plus of 3x square plus of 2x, and here the last value is minus of 3. So we'll be having, I'm just trying to help you in this way. See the negative sign over here, because it's falling down, the graph is coming down from the right hand side, and it will be having negative 3 because it's passing through negative of 3 of y. So you have to keep these things in your mind, like the graph, if it is cubic, then the highest power will be cube, and we have to draw it in this format. It's like s, right? And if the right hand side of the graph goes up, it will be positive of the graph, and if it is the right hand side falls down in this way, then it will be a negative graph. And also wherever the graph cuts the y-axis will be the last value of the cubic graph, as same as what we have discussed in the quadratic graph. Also the square graph also will be like the wherever it cuts, it becomes the value of c. And over the same, it's being discussed in the line graph also, wherever the line cuts the y will become the point c. So we'll be actually discussing some more graph, and we'll be understanding based on that also. Okay, so let us discuss here the two more graph that we need to consider here, that is uh, reciprocal graph. Reciprocal graph. Reciprocal graph, or we can call this as a hyperbola graph. Quadratic, we call this as a parabola graph, and reciprocal graph we call this as a hyperbola graph, where the equation will be like where the equation, you can see y equals to like any number or any value, like divided by a by x, right? And it should be like a reciprocal, right? You know that what is reciprocal of if I say what is a reciprocal of uh, x, so you'll be writing 1 by x, right? So why we are calling this as reciprocal? Because the value of the variable x comes down, right, in the reciprocal format, right? It is in the denominator. That's why it is a reciprocal, right? If you're having any equation in which the value of the variable x actually lies downside, it will be called as a reciprocal graph. So how it looks like? So you don't have to go deep inside this graph, but let us just briefly discuss how it looks like. So if the reciprocal graph in which we have the variable that is x that is in the denominator, then we can say that this type of graph will be having we will be having this type of graph. Make it actually this line will go and go, but it will never meet the y-axis over here, and it will never meet the x-axis over here. It will go on, and same way there will be one more curve like this one, and it will go on, but it will never meet the line. It will be like parallel to each other when we'll be like extending this graph. Okay, so this is a reciprocal graph, and we'll be calling this as a positive reciprocal graph, reciprocal graph, and we'll be having a positive of the value over here, right? And let's say if we have y equals to negative of a by x, this is also a reciprocal graph, so then the graph will be looking like this way. Okay, the graph will be looking like this way. Okay, so it's actually a negative graph. For making like much more easier to it's like to keep the concept in mind, you can understand, like if we are writing over the like x in this way, it's going up, right? And if the x goes up like that, it will be positive, right? And if this x sorry, if we are writing x over like this way, so this x looks downward, right? It's a negative graph. So you can conclude like this. It's not a logical way of thinking, but just I'm telling you how to remember it nicely. So if this actually looks like an x, if you can see, it looks like an x, right? So it looks like an x. So it goes up, right? It's look like going up. So it's a positive graph. And if the x is falling down like this, it's a negative graph. As we have discussed a lot of part, like the line which goes up, it will be positive. The line which comes down, it is negative. The curve which goes up like this one, it's a positive curve, and the curve that goes down like this, it's a negative curve. Even in the cubic curve, we have discussed, the curve in the right hand side goes up, it will be the positive curve. And if the curve that in the right hand side it comes down, it will be negative curve. The same way in the right hand side, if it goes up for this x value, so I have taken it as positive and this as negative. So you can relate all these curve graphs, so that it will be easy for you to understand. You don't have to remember all these things. Just make sure that if anything, the graph that looks above, that will be a positive graph, and the graph that looks down, it will be a negative graph. This is actually a reciprocal graph equation, where the variable that is x, that will be in the reciprocal format. And it's also called as hyperbola graph. And we have one more, that is exponential graph. So exponential curve, we call it as exponential graph, we'll call this as. So what will be exponential? Actually exponential or power, both are same actually in mathematics. So it's like y equals to let's say any number, like 2, or any let's say this is a, and that is any number, and over there we have an exponent as x. So in this equation, you can say that it has an exponent of x, right? So it can be anyway, like if we have y equals 2 raised to power x, so this will be an exponential graph. Okay, y equals to like 4 over x. So where the x is being on the exponent, we'll be calling this as an exponential graph. So let's see how the graph looks like in exponent. So if I draw this exponential graph, it will be like looking like this way. It will be like coming from here, and it will be not meeting this x-axis. Okay, it will go like this, and it will go upward like this. Okay, so if you are regular, if you are watching regularly my videos, you'll be easily able to identify whether this graph is positive or negative graph, because it's being continuous, it's being same throughout all the sequence, that if the graph goes up, right, for this, if the graph goes up, it will be a positive graph, that is y equals to a raised to power plus of a raised to power plus of x, uh, or a can be any number, right, a raised to power plus of x, right, and this falls down, right, this the right hand side, I'm sorry, uh, the right hand side goes down, right, like this one, so it is a raised to power a raised to power minus of x over here, so y equals to a raised to power minus of x. So as far we have noted in this graph, all the graph that goes up is actually a positive graph, and all the graph that comes down, it's a negative graph. So it's very easy to identify now all the graph which point towards the right hand side that goes up, it's like a positive graph. Same way, this is also a reciprocal exponential graph in which it points upward. So you can insert any number over here, like this here, can here, like y equals to 2 by x. For the reciprocal one, you can insert any number over here, so you will get it. So let me discuss one questions based on this one that will be like helpful for you now. Okay, you can see this question actually based on the graph. So in the question they are asking that uh, y equals to 2 minus of x square. Where is this graph? You know that y equals to it can be rearranged and written as y equals to minus of x square plus of 2. And as I told you that uh, any of the graph that has negative, right, negative as the magnitude or gradient, it will be like falling down. It's a quadratic graph, it's a quadratic graph, first of all you have to keep it in mind, because the highest power is 2. And in this 6 graph, where is a quadratic graph? This is quadratic and this is quadratic, correct? And I told you, if it is a quadratic graph, it should be either u or opposite to u, right? And if what case it will be opposite to u? When we have a negative sign on the magnitude, right? That is x over there, and it has a negative, right? It has a negative value over here, and we can, let me write it for you. Y equals to 2 minus of x square, and this is negative, right? And this is the constant actually. When we rearrange it, it's like minus of x square plus of 2. So here it's negative, so the graph depicts this one, the following graph depicts this one. Also you can identify the value of c, it's plus of 2 right over here. Might be like it is like plus of 2, but it's given in this format, so it's plus of 2 over here. Okay, then that's very easy, right? If see, the questions are only 3 here, but you can also check with other parts what type of graph is this. It's not an issue for doing all the questions. You can also refer some of the questions from other past papers for much better practice. Okay, so here the second part is y equals to 2 raised to power minus of x. Just now we have discussed that anything raised to power something, right? It's actually exponential graph, right? You should remember, right? If I write x cube, so it's an exponential part, right? Same way we are. The 3 is exponential, so here they are trying to give you that exponential graph in this format where x comes in an exponential, right? And just now we have discussed, if x is having a negative value, so it will fall down. So the graph is falling down. This is the graph we have to select, because this graph is only falling down, right? And because this graph is going up from the right hand side, we will not take this graph. So actually this is the right graph, we have to take it. That is the, we can write this as b. Okay, so if they have given you plus of x, then you should have selected this one. Yeah, so and this y equals to 2 by x, you can see that this is a reciprocal graph, or we can call this as a hyperbola graph. And in this the x should be in the reciprocal format, right? Everywhere the x is being affected, here the x is in the reciprocal format. If it is reciprocal, right, so you have to just check for the x, right? So because it's a positive of the value positive of x, so you have to go for this x, right? I told you this x, which looks at the top. So because this x is falling down, right, this x looks like this one, right? So this will not be the answer for this one. We have to take this x that goes up, right? So definitely this part will be the answer for the C. I hope you understood a little bit about the graph. Okay, so let's move on to the question.